Okay guys, so today I will be explaining about the properties of circles. So before we continue, there are four prior knowledge that you need to understand before I explain any examples. Okay, so the first one is the name of the theorem is the angle in a semicircle. The statement is the angle in a semicircle is a right angle. So if we see here, we have a semicircle and then we have point B, or point B is on the circumference of the circle, and AC here is the diameter of the circle. So if we connect point A, B, and C, okay, so the triangle here will be a right angle triangle. So the B here is always 90 degrees. Okay, so the second one, the second theorem, the name of the theorem is chords of a circle. So the perpendicular from the center of a circle to a chord bisects the chord. So if we have a chord like this one here, AB, and then we connect the center of the circle to line AB perpendicularly, like 90 degree. So this line here will bisect the chord. So the length of AM will be equals to BM. The third theory is about the radius tangent. So the tangent to a circle is perpendicular to the radius at the point of contact. So the point of contact is in here. This is what we call the tangent here, the line in which it's contact the circle only in one point. We call it tangent. And if we connect the center point to the tangent, like this one here, perpendicularly, it will be always 90 degree, like this one here. So the angle of like TAO or OAT is equals to 90 degree. And the last one is tangent from an external point. Tangents from an external points are equal in length. So if I have a point outside the circle here, and then I have a tangent in a tangent of a circle here, we have one circle, and then we have a point outside the circle, and then I connect the the point of contact of these two tangents of the circle, the length of AP and BP will always the same. So these are the four basic knowledge that you need to understand before I continue. So let's have the first example. So in here, find x giving brief reason. So in here, as we see, the x in here and in here are related to angles of this triangle, right? So as we know from the first theory, the angle in here, right, will always be 90 degree, right? So because these three are angles in a triangle, so as we know that the sum of the angle in a triangle will be equals to 180 degree. So using this theory and using the theory as we know from this circle in which this is not will become 90 degree. So if we add all of these angles, it will become 180 degree. So in order to find the value of x, so you need to write them down in an algebraic form. So you only need to add this one here, and this one here, right? So you need to write down x plus 10 plus 3x plus 90 equals to 180, because we know that the sum of the angles will always be 180 degree. So this is from here. So simplify any like terms. If we have like this one here, x and 3x, we add them up, so it will become 4x, and we have 10 and 90. 10 plus 90 is equals to 100, so equals to 180. So you only need to solve this simple algebraic equation. So you move this 100 going to the other side, the right side, so it's 180 minus 100, which will be equals to 80, and the 4x equals to 80, so x equals to 80 divided by 4, so x will be equals to 20. Example number 2. A circle has radius 4 cm and a chord of length 6 cm. Find the shortest distance from the circle's center to the chord. So if we illustrate this question, the image will be like this. The image of the questions. So as we see here, the radius is 4 centimeter, right? And then we have a chord of length 6 centimeters. So let's say I draw a chord AB, this one here, from here to here. So this line here is the chord, right? This is a chord. And then we have a radius of 4. It means that if I connect this center point to point A and to point B, these two, this will be the radius, and this is also will be the radius, right? Okay, so as we know, if we know that, if we see here, we will have a triangle, right? So because this length here will be equal to this length, so this is an isosceles triangle. And then as we know from the second theory, the shortest distance from the center of the circle is the perpendicular distance. So if I drag a line from the center of the circle to line AB perpendicularly like this, right? As we see here, we have a right angle triangle, right? So notice that we need to know about the Pythagoras theorem also to solve this question. So what we are looking for is this one here, this line here, the length of this line. So name this with x. So if I draw again, it will be a right angle triangle like this. So let's name all of the sides because this one is x, right? So I'm going to name that with x. And in here, this one here is 4. So this is 4 centimeter. And this one here, notice that this line bisects this chord. So it means that if the length of AB is 6, so the length of AM is just you divide this by 2, right? So 6 divided by 2 is 3. So this is 3 and this is 3. So this is 3 centimeter. As you know, because this is a right angle triangle, you can use the Pythagoras formula to find the value of x, right? So use this c squared equals to a squared plus b squared. And remember that this c here is always the hypotenuse, and the hypotenuse is the longest side or the side in front of 90 degrees. So this one is the C. Let's name that C. And for these two, the legs of the right angle triangle, we name it A and B. It doesn't matter which one is A and B. So you can swap them around. And we only need to plug all of these values into the formula. So let's name those. So it's x squared. So the a is x squared. So I'm going to write it down. A squared plus b squared equals to c squared, right? And the value of a is x. And the value of b is 3. And the value of c is 4. Right, so you do the same thing like this one here, right? So you only need to square all of them. So it's x squared plus 9 equals to 16. So x squared is equals to 16 minus 9, which is equals to 7. So because this is a square, so x will be equals to square root of 7 centimeter. So this is the shortest distance from the circle center to the chord. Example 3. The tangent from point M to the circle of radius 5 cm is 12 cm long. Find the distance from M to the center of the circle. As we see, the image is like this, right? The image from this question. As we can see, the tangent to a circle always make 90-degree angle. So if we connect OT as the radius, so this is the radius of a circle. Remember that a radius is the distance from the center of the circle to the circumference, and it's TM or MT is the tangent. It means that this is going to be 90 degrees. And as we know, because this question is find the distance from M to the center of the circle, so from M to the center of the circle, if we connect them and we shape this, we know that this is a right angle triangle, right? So this is a right angle triangle. And because this is a right angle triangle, and so if you want to know the value of or the length of OM, we can use the Pythagoras formula to find the length of OM. So the radius of, I'm gonna write down the vertex, and we write down any values that we know from the questions, and we know that OT is the radius, so it's just 5 cm, and we know the TM is 12 cm. And The Pythagoras formula is c squared equals to a squared plus b squared. So the first thing again, to determine the value of the hypotenuse. Remember that the hypotenuse is the longest side, or the side in front of 90 degrees. So this is the hypotenuse. So let's name that with c, right? We only need to plug all of the values here. So this is a and b. So again, remember that a and b can be swapped, but not the c for this case. So the value of c is just c, right? It's the OM. And then the c square will be equals to a is 5, so it's 5 square plus b square, so it's 12 square. C square equals to 25 plus 144, which is equals to 169. So ski is equals to square root of 169. It will be 13 centimeters. So the value of the length of OM will be equals to C, which is equals to 13 centimeters.